morning. Good, I'm going to talk about tomatoes today. No, seriously, I'm going to talk about maps because that's what HERE does. We make maps. We have a 30-year legacy of making maps. And we are in 4 out of 5 car navigation systems. So our maps are used daily around the world. But what I want to talk about today is the new map, because maps are going to change. They're going to start to make decisions for you in real time with real-time data to get you through your daily activities. So you're probably thinking about a very popular crowdsourced traffic app, but that is just the beginning. And as some of you that may have used it, sometimes it doesn't work very well. So there's a lot of challenges going forward with these kinds of applications. But more importantly, vehicle data is coming. You may not know this, but we were just purchased. We used to be a Nokia company. We were just purchased by Daimler, Audi, and BMW. And the connected vehicle is coming. The automated vehicle will come someday. But vehicle data is coming to us, and it's very rich, beautiful data. What it will allow us to do is understand more about how people experience the road network. And you can think of a lot of different applications for that, and hopefully I'll stimulate some ideas for you. In addition to the vehicle data, of course, we know IoT is coming. So IoT is big data, vehicles big data, so we got lots of data coming our way. We've got all these computational tools that are fingertips now, Hadoop, and all of those kinds of tools readily available, all the Spark apps that are available now. And we're going to have a lot of challenges on how we manage this data, how we compute, where we compute, what we do with this data. And I believe what we'll see is a very dramatic shift in computing solutions. And I'll tell you a little bit more about that as I go forward. So I would propose to you that maps are a part of us. It's part of our DNA. We have been making maps since the dawn of civilization. We have a need to know where we are and what's around us. And we make a lot of decisions based on our location. And a lot of our businesses work on location. Location is a framework that has been with us since the dawn of civilization and will continue to be so. So maps are very key going forward with these computational systems. We've been making maps for 30 years, digital maps. So digital maps are completely different than those nice 2D flat maps that we unfold or used to unfold. Some of you are probably young enough that you don't even do that anymore. This is 3D photorealistic building objects on top of our digital elevation map. So that is a very sophisticated computational structure. And those 3D building objects, which I can locate and place things in, were generated automatically from photogrammetry from flying above the city. So maps are a whole new thing that you don't think about when you're just looking at your smartphone trying to figure out where you are on that canvas you're looking at. Sometimes that's a little bit too much for our cognitive load, so then we can automatically turn them into abstract buildings so that they're easier for you to process as you're driving a car. What we do to create the lane level maps is we have vehicles that drive through the city that are equipped with LiDAR, spinning LiDAR systems, and cameras to create point clouds of the environment. And those point clouds are at centimeter accuracy. And they also give us intensity back, which means we can pick out lane markings, signs, and a variety of different features in the environment. So building facades, curbs, traffic signs. You can colorize that 3D point cloud now with those camera images that you have, so you can get a much more sophisticated understanding of the environment. So here's my buzzword slide, just to get it out of the way. Pervasive data-driven cloud-enabled Internet of Things is coming. There is no question it's coming. And all those people have different devices. They'll have health monitoring devices. They have their smartphones. They have their Fitbits. They have all these different things, all giving us different kinds of data in different kinds of ways. And that's what's really significant about what's happening now. Because big data has been here for a very long time. I used to work in the DOE National Labs doing high energy physics. We dealt with petabytes of data 20, 30 years ago. Big data is not big news. What's really interesting is now I have uncurated data coming to me that I have no control over. So those devices are all specialized little things giving me information, and I have to make sense of it. So now we've got the 5 V's of big data, the velocity, volume, variety, all that kind of thing. But we've also got things like veracity, which is a V word, because it has to fit in the V word paradigm, is for quality. So we've got quality, and now with this big data, I would suggest to you that you also need visualization, because it's really hard to understand your quality without that visualization. And the last one is most important, and that's value, right? So you can spend bucket loads of money and resources on big data and this kind of activity and get no value out. And there's a lot of good examples of it. So you really, if you're getting into this business, you really need to understand the value proposition and understand how hard this is. So I would suggest that we've got the Internet of Things coming, which is giving us local activity, geospatial localized activity. The big data is coming with it that allows us to do models and discovery and prediction. And I would suggest that the third piece to it is hyperlocal. So hyperlocality is what makes it relevant to you as a human being. So all the big data in the world, I don't care. I care what's around me. I care about what's happening with me. And thank goodness for the networks that are coming, because they are here. So now we have bandwidth everywhere. When I first started doing OnStar, which was 16 years ago, we were delivering telematics over analog networks. There's old Cadillacs out there with analog radios in them. So that's how fast this has all changed. And it's this confluence of the Internet of Things, the big data tools, and the networks that is going to dramatically shift what we can do going forward. So forgive me for taking a multi-dimensional space and trying to make it really simple, but I try to at least communicate. If you think about geospatial extent on one axis, and you think about all the annotation that we put on here. So we put transit lines, we put construction zones, we put traffic. We layer that all up on top of the map. That's how complex this digital space of maps has become. And then because of the big data capabilities we have now, we can capture it all in time. So it's huge, huge. We're calling it a Koro space, Koro being the Greek word for place. So these maps now are something completely different than we ever started doing. We started doing cartography, and now they're very, very distinct and complex instruments. And they will become your companions, your advisors, your assistants. And that smartphone you carry, that big brick that you're carrying, I wouldn't doubt if that's gone soon. And that you have devices, bracelets that are telling you, messaging you, telling you information. You've got a radio in your pocket. And the smartphone and the visual goes away. So what does this data look like? This is probe data. Probe data is information from vehicles, PNDs, smartphones, lat long speed heading, device ID, and sample time. So that's good data. It's colored by speed. It's downtown San Francisco. It's a mess. It's an absolute mess, right? That's multipath issues from GPS data, right? You can't tell what's going on down there. With sophisticated analytics, we can actually pull those purple lines there. We can pull the road network out of that. See those green lines? Again, colored by speed. That's junk, just junk. And when you start working with this data, you'll find there's a lot of junk in there that you don't want. And that's why I really push on veracity, because the data can only do what's in it. All the analytics in the world are not going to help you if the information is not in the data. That's why you need these visualization tools. Now, this beautiful image is cell phone traces colored by speed for Los Angeles. Now, we get those cell phone traces, they're chopped up into little bits and pieces because of privacy. So we don't have nice, long, pretty traces. We have just lots of little bits and pieces. And look how rich this is. You can see LAX, the LA airport down here. You can see the main arteries for access to the city. Very, very rich data. That's Amsterdam. It's not as pretty up here as it is on my Retina display, so you should come and look at it on the Retina display. That's Eindhoven, which is just outside of Amsterdam. We're opening a research center there. So you can, I mean, just look how beautiful these images are. They're stunning. That's the wrong direction. What do you think this is? I always say it looks like something out of a microbiology class textbook. What that is it's London. It's exactly the same data and exactly the same tool visualized poorly. So London tells you a whole different story. So visualization becomes a key part of this big data problem. So as I mentioned, data defines its value, and analytics can do certain things. So now here's an image of that same town, Eindhoven. And what we've done is we've taken these traces and we've looked for places where people dwell in space and time. So that gives us an idea of mobility in the city. What people are doing, where are they doing things? And actually those on the bottom right there and the top left, those are manufacturing facilities. So you see a lot of people going to work and staying there during the day. So you can learn a lot about how the city operates from just this data that we're getting from all these devices. This is Eindhoven again. That one before was Amsterdam. This is on the left here is where we think congestion happens in the city based on this probe data. And this on the right in blue is where we think people stop and shop, go to coffee shops, go to restaurants. So with these analytics, you can pull out a lot of information from this data that we're collecting. Now, vehicle data is coming. This is an example of some vehicle data. This is CAN bus data. So CAN bus means we have access to brakes and airbags and all those other kinds of things that are in the vehicle. Vehicle is a beautiful device because it's got a big fat battery on it. So we don't have the problems with smartphones with battery drainage and all that kind of thing. And so these guys are coming into the sharp curve. Since we have CAN bus data, we can figure out where they start putting their brakes on. This fellow here decided to brake at the very last minute. I always joke he ended up in a tree down here. So that's why you want the wisdom of crowds for driving, right? You want to pile up this data and learn from how people actually experience the road network. So you take the centroid of where people tend to brake. This is really good information for civil engineers on where to post signs. But think about a teenager. Think about a teenager coming into this curve. They say it takes 10 years to learn how to drive. So you can build assistants that sit inside the vehicle that says, you're coming in too hot, you gotta slow down. It's time to put your brakes on. So people that have never been there, elderly people, this could be great for safety situations. I did follow that fellow. This is the way a normal person I shouldn't say normal person, comes through the curve. They slow down, and then they start to accelerate about right here. I did follow him. I say him, too. That's unfair. He doesn't start accelerating until way over here. So I always say he's composing himself right here. Right? So he took that turn way too fast. Now, what we've learned is as people went through that curve, there was a lateral acceleration, the g-force, that it kind of capped out at. Everybody stopped at the same kind of lateral acceleration, which says to me that there is a lateral acceleration that we as human beings like to experience. So this is going to be really important when we get to automated vehicles, because people are going to be more likely to take their hands off the wheel if the vehicle actually drives like a human being. So that's the northbound lateral acceleration. It's computed because we have curvature information about the road network. And so depending on what the speed is they took, you can compute that. And what's interesting, it's different in northbound and southbound. And guess what? It's different in rain. And it will probably be different in snow, and different at night, and different at day. And you can start layering that up on top of the map so that you can control that vehicle or provide assistance to someone else who's driving that vehicle. Once again, the wisdom of crowds for driving, not just one trip through the curve. Even if it's raining, let's say you've got coming into a really big rainstorm, you want to tell people to slow down. It's dangerous up ahead. We looked at the windshield wiper activity on these vehicles. You can imagine that this person could broadcast to anybody who's coming this way. So now you've got systems that can help people understand safety issues up ahead. This fellow who just entered the rainstorm, maybe he's going over there, so we can have systems that will reroute him around the rainstorm. And we believe that we can localize the rainstorm quite well this way. And this is only 120 vehicles. So what the beauty of big data analytics is it allows you to predict. So you can do things like taking all this probe data, starting to smooth it to understand this is a distance along Highway 101 in San Francisco area, which is where I live. And you can start to see the traffic jams forming. This is, again, colored by speed. But with all this big data tools that we have now, you can start to build models for every link in the map. And what we've done is we only show 10 here because your eye can't discern. We've built 30 models on each link on the traffic map. And then what we do is we take all those models and the link and the data that's coming in, the probe data that says people are moving along this link, and we take that data and we pick from that model set what we think is in play today. So now we can start to predict what we think the dynamics of the roadway are going to be. All because we have these big data tools. This is all written in Storm and in the AWS. And this is just a quick plot to show that it actually works, and I'm going to run out of time because I'm watching you look at your watch. So I'm going to go very quickly. We can also do things with traffic jams. And traffic jams are like finding a needle in a haystack because there's so much congestion out there. How do you find a traffic jam? So we've done machine learning to try to find traffic jams amidst all this chaos that's out there. Now, I'll keep going. I would suggest that we are now moving to edge computing, because the question is, where does the computation occur? Does it occur at the device? Does it occur at routers? Does it occur in the cloud? And we tend to think of device and cloud. And I would suggest to you that we are going to do it at all levels. And that is going to introduce geospatially distributed computing. And it will make you rethink how you build your applications. And I will skip the video there. And I will finish up with another piece that I think is very important, that we talk about the economy of sharing, But I would suggest that context is one of the key things for value generation going forward. And context is your state, your preferences, and your hyperlocality. What is going on around you, and being able to take the big data, turn it into little data that's relevant to you. And if you think about what Uber is, that's exactly what it is. You're standing on a street corner, you need a ride, and it does a hyperlocal search to get you what you need to get you where you need to go. They haven't done preferences yet. They will soon, I would suggest. And all of this is pushing us towards the notion of the living city, where we can take all those models and model the street networks. We can start putting parking in there. We can start putting all of the dynamics of living cities together so that we can make these cities places that you and I all want to live. So I will leave it there, and thank you for your attention.